we are starting with some basic formulas of derivatives, you can say. So derivatives, or we say it is differentiation, D-I-F-F-E-R-E-N T-I-O-N. Okay? That is differentiation, or that is derivative. Now if I tell you very first formula for derivative, we say it is d by dx of x is always 1. How we read this? We read like this: derivative of x with respect to x is always 1. Same way we can say here d by dt of t is also 1. Now means what? Derivative of t with respect to t is also 1, and hence on. The second formula for derivative, we can say here derivative of constant is always 0. Constant means any number. If I tell you example of this, d by dx of 3 will be 0. 3 means constant. Second, d by dx of 5 square is 0. So these are examples you can say. You can say 5 square, you can say 3, you can say -4. Whatever be the constant, derivative of that is always equal to 0. So first formula was derivative of x was 1. Second formula we did derivative of constant is 0. Now we switch over to formula number 4, you can say. Okay. Now formula number 4, we say here derivative of e raised to x is always e raised to x. See here. What I said, derivative of e raised to x is e raised to x. Fifth formula, we say derivative of a raised to x is a raised to x into log a. What I said, derivative of a raised to x is a raised to x into log a. Fifth formula. Again I can take examples of this also. If I take an example of this, derivative of d by dx of 5 raised to x is obviously 5 raised to x into log of 5. Since I said a raised to x, so a raised to x, I said a raised to x into log a. So 5 raised to x was 5 raised to x into log 5. I can take one more, derivative of 3 raised to x. So this will be 3 raised to x into log of 3. So we got now formula number 5, and we had shown examples of that also. Okay. Now formula number 6. What is that? Derivative d by dx of log x is always 1 by x. What I said, derivative of log x is always 1 by x. Seventh formula, seventh, very important one, very important. We say derivative of x raised to n, and your formula is n into x raised to n minus 1. Very important. I can put a star mark on this one. This will be used regularly. Okay. Example of this again. If I tell you derivative d by dx x raised to 4. Okay. X raised to n, formula was nx raised to n minus 1. X raised to 4, n is 4 now. So your formula will be 4 into x raised to 4 minus 1. And that means 4 into x raised to 3. So this is your formula for, or answer for derivative of x raised to 4. Next I can give examples, many examples I can give. I can say with a derivative of x square. Derivative of x square. X square means n is 2 now. X raised to n. N is 2. By your formula, I can say n, that is 2. X raised to n minus 1. N is what? N is 2. So I can say 2 minus 1 directly I can say as 1, or in next step I can say it is only 2x. So that is derivative of x square. Next I say here d by dx of x raised to minus 3. Now we are taking negative power. X raised to n, we took x raised to 4, 4 was positive. X square, 2 was positive. Now I took this one. Again formula is same, n. What is n? Minus 3, n into x raised to n minus 1. So x raised to n minus 1. So that is minus 3 minus 1, that is nothing but minus 4. Or the same I can simplify as minus 3 upon x raised to 4. X raised to minus 4, if we can take in denominator it will be x raised to 4. The next same if I proceed, we say derivative of beta root x. Root x. Root x is now fraction. So we can say, we can simplify as derivative of x raised to half. Root x. Root means x raised to half. Now your n is half now. Same formula, it is n. N means half. N into x raised to n minus 1. So that means it is 1 by 2 x raised to, we solve this, half minus 1, 2 goes that side, that means 1 minus 2, that is we get as minus 1 by 2. Final calculation, 1 upon 2, this comes in denominator. So this will be x raised to 1 by 2 by indices. This is x raised to minus 1 by 2. We take this in denominator, it will be x raised to 1 by 2. And finally, x raised to 1 by 2 is also root x. Okay. So this is as good as new formula now. We can add this in your formulas. Derivative of root x ka derivative will always be 1 by 2 root x. Okay. So we are adding this in your formula. Root x ka derivative will always be 1 upon 2 root x. So just roughly you can say an idea of what we have done, what is there on the board. We started with first. What was that? Derivative of x. So derivative of x is 1. Formula number 1. Very first formula. Second formula. Derivative of constant, that is k, is 0. Formula number 2. Third formula. What was third? In this one, it was derivative of e raised to x. That was directly e raised to x. Formula number 3. Derivative of a raised to x. What was that? A raised to x into log a. Formula number 4. Next, formula number, you can say 6 it is given. It is normally 5 you can say. So derivative of log x. What is that? It is 1 by x. Derivative of x raised to n. What is that? N into x raised to n minus 1. And finally, we wrote derivative, we derived actually. This is derivation, or you can say we just found it out. So derivative of root x is directly 1 by 2 root x. So this is how we have got these formulas. I am proceeding now, I am extending this now. So let this be, you can say formula number 6 we are done. I can extend this now. I am taking some more examples on this one. So same formula, this is I am extending, this is I am extending. I am telling you, what about derivative of 1 by x? What I said, derivative of what? 1 by x. 1 by x we write as x raised to minus 1. What I said, 1 by x is x raised to minus 1. Again same formula, x raised to n. Your formula is n, x raised to n minus 1. Shall I say minus 2 then? So that means it is minus 1 by x square. So again you can add up this in your formulas. Derivative of 1 by x is always minus 1 by x square. So this is what actually, it was formula number 6 you can say. Root x ka what we did? Root x. To root x we can say formula number 7. And the one what I got just now, we can say this is formula number 8. But this is what is done. Okay? So this was all about, you can say, algebraic, logarithmic, exponential. Now we'll be switching over to a little bit of trigonometric functions now. Okay? I'll just rub all these formulas now. So this was your basic simple formulas of derivatives. Now we'll be switching over to trigonometric and inverse functions. Now this is formula number 9. We say d by dx of sin x, derivative of sin x. Derivative of sin x is always cos x, directly cos x. 10th formula, derivative of cos x is always minus sin x. Next, 11th, derivative of tan x is always sec square x. This you have to by heart now. Then 12th, derivative of cot x is always minus of cosec square x. 13th one, derivative of sec x, and it is sec x into tan x. Then 14th one, derivative of cosec x, it is minus of cosec x into cot x. So these are very important formulas of that is trigonometric functions. Again I'll repeat, derivative of sin x is cos x, derivative of cos x is minus sin x, derivative of tan x is sec square x, derivative of cot x is minus cosec square x, derivative of sec x is sec x into tan x, and derivative of cosec x is minus cosec x into cot x. I extend it, I proceed this. Now inverse functions, inverse, formula number 15. We say derivative of sine inverse x. Your formula is 1 upon root of 1 minus x square. देखो ठीक है, what I said, sin inverse x का derivative is 1 upon root of 1 minus x square. 16th one, derivative of cos inverse x. Formula is same, only minus 1 upon root of 1 minus x square. Plus and it is minus. 17th one, derivative of tan inverse x. It is 1 upon 1 plus x square. Then next, it is cot inverse x. So this is minus 1 upon 1 plus x square. Then we have derivative of sec inverse x. It is 1 upon x into under root x square minus 1. And finally we have derivative of cosec inverse x. It is minus 1 upon x into under root x square minus 1. So this was all trigonometric functions. This is all inverse trigonometric functions. Again we'll repeat. Derivative of sin inverse x is 1 upon root of 1 minus x square. Derivative of cos inverse x is minus 1 upon, only 3 derivatives, only sign is changed. Sin inverse x का plus है, cos inverse x side is negative, minus है. Derivative of tan inverse x वही है, 1 upon 1 plus x square. Cot inverse x again it is minus 1 upon 1 plus x square, only sign is changed. Derivative of sec inverse x, 1 upon x root of x square minus 1, and same way derivative of cosec inverse x is minus 1 upon x root of x square minus 1. So this is all basic formulas of derivatives. In next lecture we'll be taking problems on this topic. Okay? Thank you.